going to be doing is we are going to take a virtual wall walk. So here's what the wall walk consists of. I want you guys to take a moment and I want you to look at all of the different types of walls you notice here on this flip chart, okay? I want you to look at what is the wall made of, okay? Look at how it is designed, all right? So take all of that in for a moment. Now what I would like for you to do is I want you to think to yourselves, what type of walls have you seen in your everyday life? You don't have to share with me, but I want you to keep it inside of your brain. So here we go. It says wall walk. Directions. Take a walk and look for different kinds of walls. Again, we're not taking a real walk. We took a virtual walk. In the boxes below, we're going to draw pictures of 4 different walls that you have seen or pictured in your mind. If you recognize any of the materials used in the walls, you're going to label them. What are 4 different types of walls that you've noticed in and around where you live? Yes. All right, time is up. Go ahead and put your pencils down. So today, you guys are going to have a task. You are going to have a chance to design and construct a wall just like Yi Min and Chen did in our book, Yi Min's Great Wall, okay? Your wall will be made using rocks and mortar, okay? What do you think the mortar is going to be used for?
To put the rocks or whatever thing you're using to make the wall to stay together.
Oh, very good. So now what I'd like us to do is I want us to think to ourselves, what are some properties that you think a good mortar should have?
Does not fall apart easily.
Okay, any other ideas? Thick?
It needs to be like dry after they build the wall.
Okay, so it needs to be able to dry.
Yes.
Okay. All right, good job. So with the task that we are about to do, we are going to be doing the very first step of the engineering design process. Boys and girls, what is the very first step in the engineering process? Everybody? Very good. So in order for you to complete this, you need to be able to figure out what are you trying to find out and what do you need to know. So our question to ourselves and what we are going to be asking ourselves is, which materials make the best mortar? All right, so what we're going to do is you're going to take a look at some dry earth materials. You're going to observe the earth materials when they are dry, and we're going to write our observations of the materials in this chart. So the 3 earth materials that we will be using are soil, sand, and clay. Okay, so I'm going to show you those materials, and they're going to be dry. You will now go ahead and you will observe the 3 different samples. Okay, talk with your team member about what you see, and please do not open the bags.
The color is like a kind of whitish, tannish. Has so much cracks in it. This feels so weird.
All right, go ahead and take your dry materials, put them back in the center, and let's talk about what we observe with our dry materials. Let's first talk about the soil. What size are the particles? Are they small, medium, or large? Yes?
Small.
Okay. Are all the particles the same size? Do the particles of the soil all look the same size to you? Yes. Okay. What color is the earth material? We're talking about the soil. Joey?
Black.
Very good. How sticky is the earth material? Do you think that the soil is not sticky, a little sticky, or very sticky? Madeline?
A little sticky.
A little? Okay. Next up, let's talk about the sand. All right. While Marilyn is collecting the dry earth samples, I'm going to pass out some wet earth samples, okay? So we are now going to fill out a chart where we are going to tell about the properties of the wet earth materials. You may go ahead now and you may observe the materials. Use your hand lens. All right, guys, so now let's talk about the properties of the wet earth materials. We have here, what size are the particles of the wet soil?
They're small. Wait, they're medium.
They're medium?
Medium.
Are all of the particles of the wet soil the same size? Joey?
No.
Says no. How sticky is this earth material? Is the soil not sticky, a little sticky, or is it very sticky? Juan?
A little.
A little sticky? Okay. Let's go ahead now and talk about the sand. What size are the particles of the wet sand?
The particles of the wet sand are small.
They're small, okay. All right, so we're now going to make some predictions. Do you think we should be making mortar out of wet or dry earth materials? And tell me why. Madeline.
Wet because if they're dry, it would just all fall apart.
Okay, very good. What material properties do you think will be important for an effective mortar? So what properties must the mortar have in order to be good mortar? Yes.
Smooth, like kind of hard and wetish.
Okay. What else, Kenya?
Softest.
It needs to be soft, according to Kenya. Yes.
Sticky.
Sticky is a very important one, I think, that we've noticed. All right, so here is the work part we got to put in. So what you're going to get is some materials in just a little bit. You'll get some tiles, okay, like this. You'll also get, well, actually, you have already your mortar mixtures. So you have soil, you have sand, and you have clay, all right? You will make 2 soil sandwiches, 2 clay sandwiches, and 2 sand sandwiches. You're making 2 of each, okay? As soon as you get your material, you may begin.
I'm gonna do sand. I like it.
All right, guys, I need for you to take your circles, go ahead and put them on the table. So at this point, our mortar sandwiches are complete. They will sit on the circle table and they will dry overnight. And then tomorrow will be step 2, which is testing our materials, okay? Here, I have my mortar sandwiches from yesterday. One set is going to be used for the sticking test. The other set is going to be used for the earthquake test. Does everybody understand? We're going to do the test together. All right? So are we ready to test? Pick up and let's count. 1, 2, 3, 4.
10, 11, 12, 28, 29, 30.
Okay. What do you notice about the properties of clay? Can anyone tell me? Marcus.
It's sticky, bendable, and also rollable. You can sculpt it to look like anything.
Okay, thank you. So a very important thing that he noted is he said he noticed it was very sticky, okay? And that is a good indicator that lets us know its stickiness was based on the test that we just did. It did not come apart. All right, let's get ready for test number 2, the soil. All right, so our next test is the soil. Lift. 1,
2, 3, 4, 5, 6, 7, 25, 26, 27, 28, 29, 30.
Ooh. Would any team like to share with me what happened when you just tested your soil sandwich? Sky.
It came off.
Why do you think that happened?
It was probably because we didn't put enough soil.
Was there any other group that had a similar circumstance as Sky did? Any other group? Yes. And why do you think that happened?
Maybe he didn't get enough stickiness.
What would make it sticky?
Maybe more soil.
So you think it needs more soil. What do you think, Ross?
More water?
So maybe it's lacking a little bit of water is what Ross just said. Now, let's go ahead and let's do our last test, okay? Sand. So again, as a reminder, just lifting the top. All right, here we go. Lift. 1.
0.
Oh my goodness, so not even a number. We literally just counted to nothing. Exactly. Talk to me about what just happened when you tested your sand mortar. Let's go with Kenya.
The tile didn't stick to the sand because the sand got really dry.
It was dry, okay. Well, let's go ahead and we are going to take a look here. It says here, for each test, circle the mortar that worked the best and put an X through the mortar that worked the worst. Caitlin, why don't you go on up, grab the pen, and I'd like for you to circle the sample that did the best. Which was it? Agree or disagree? Agree. Agree, very good. We noticed that the clay did the best. I would like it if Kenya would go up to the board. Can you put an X through the material that did not work so well? All right, thank you, Kenya. It is now time for us to move on to the earthquake test. Remind me again of what is the earthquake test testing? Anthony, do you remember?
We're testing strength.
That's right. Very good, Anthony. So I'm going to show you how to do the earthquake test. Okay. It says here, shake the plate so that your mortar sample is moved back and forth between the two lines 5 times. I will show you how that is done. If you notice, you'll notice that there's an arrow going up and down. So your job, boys and girls, is you will take the plate with the sample that we're going to select first, and you are going to move in an up-down position like this. So when you reach this top line, you don't go beyond it. You stop right below it. Are you ready? All right. Remember, we're counting to 5. Here we go. We can keep going. We're at 3. We can keep going. Okay? Talk to me about what happened. And why did that just happen during the earthquake test? And what does that tell you about sand's strength? Yes, Joel?
That's not it to really weak and it doesn't really have strength at all.
It doesn't. And how do you know that?
Because it just fell apart and some of the sand escaped to the tide.
It did, Joel. It definitely did. Okay, guys, so I've done enough demonstrating. So right now, the person who is doing the earthquake test, in front of them should be their plate, okay? On the count of 3, we're going to do our test for 5 seconds, okay, or 5 pushes, okay? 1, 2, 3, test. Stop right there. So what did you notice after testing the soil mortar using the earthquake test?
Ours stayed.
Yours stayed, okay?
Ours crumbled.
Oh my goodness.
Ours crumbles as well.
Oh, wow. Interesting. All right. So in the beginning, or before every test, we made predictions. Did all of your predictions match your results?
No.
Tell me about it.
For the clay, I thought it was going to stick together, but no.
No. Okay. What about you, Nicholas?
Not really, because the clay and soil, I thought they were going to stick, and they did. But the sand, I never thought it would do that.
All right, guys. So we've tested both the stickiness and the strength of all of our earth materials. All of the earth materials have both good and bad properties, okay? Some of them were excellent at sticking. Some of them were very, very strong. But you need to understand that they all come with both good and bad. I definitely think with building the mortar sandwiches that the students had some preconceived notions. And I think it was very poignant for them to see, okay, these materials act and behave very differently when mixed with another material, which happened to be water. Again, it goes back to our lesson 2 example, which was you think a material is going to be one type of way, and then you find out it's completely different. And it's because it has these different properties that allow it to be great in some instances and maybe not so great in other instances. And I think in lesson 3, it also piqued their minds to think about the fact that maybe we can combine materials and make something better.